Welcome everyone. Today we are going to learn practically the applications of the Ohm's law using the NI Elvis hardware which we have in the lab now and also the LabVIEW. Now today we are trying to apply the Ohm's law using a resistor, a simple LED and a variable supply provided on the NI Elvis board. Now as you can see here, we have a variable power supply available on NI Elvis board to which we will be connecting a resistor via an ammeter. So whenever we change the voltage V, the current passing through the circuit I will be measured by the ammeter here, and you can see that since the resistance R is fixed in the circuit which is present here, the ratio of V by I will always remain constant since R is a constant. The series resistance of ammeter is normally considered to be very small, so we don't have RA in the circuit. Now the resistance which we have employed in the current circuit is approximately 2.2 kilo ohm. Now along with it, for a proper visual understanding, I have also kept an LED parallel to the resistor. So whenever the voltage across the resistor changes, we can see the changes. We can see the change in voltage as the change in intensity of illumination of the LED. So as you can see on the second half of this screen now, we have written a VI for controlling the variable power supply V to see whether the current I is changing in the circuit or not. So we have a slider here mentioned as supply V, and there is another text box showing the amount of current in milliamperes as measured by the DMM on NI Elvis board. Here we have DMM. These are the connections to the DMM. So now as you can see, when I am applying 3 volts in the LabVIEW, you can see that the current is coming out to be 1.39 milliamperes approximately. So you can also try to see the current I as V by R, so which becomes 3 by 2.2 kilo ohm, comes out to be approximately 1.3 milliamperes. So as I increase the voltage, the input voltage, or decrease the input voltage, you can see that the LED present on the prototyping board changing its illumination. Say for example, now I am bringing it to 4.5 volts, the input supply to 4.5 volts. So now the LED is glowing brighter, and as I decrease the input voltage, you can see the LED glowing much less brighter than the earlier cases. But in all the cases, as we increase V, we can see the current increasing, but the V by I ratio, which is nothing but resistance R, is always being retained at 2.2 kilo ohm or 2200 ohms approximately. So we'll start at 1 volt and then we'll go in steps. So let us say for example, now input voltage V is equal to 1 volt and resistance R is equal to 2.2 kilo ohm. So the current I in the circuit is equal to 1 volt by 2.2 kilo ohm, which can be seen as 0.4 milliamperes respectively. So you can see the same thing running here in the LabVIEW. And similarly, if I increase it to 2 volts, now it's approximately 0.89 milliamperes, which is shown as 0.9 amperes, 0.9 milliamperes in the LabVIEW. So as we increase the voltage, we see the current doubling every time in the LabVIEW. So from this we can see that the V by I relationship when we have a linear element like resistor in the circuit is always true.